This is Unit 3, Earth's Place in the Universe, which relates to Earth science. And this unit will include the study of Earth and the role of its planets in the solar system. To briefly summarize, Earth science is a field of study that focuses on planet Earth and its various processes. It contains a wide range of topics such as geology, meteorology, and environmental science. It can be also related to ESS. And the whole science concept analyzes Earth's physical characteristics, natural phenomena, and interactions between different components of the Earth system to better understand how the planets function and evolves over time. But the study will also include a concise overview of the solar system as well. So starting off with the statement of inquiry, as always, it states, exploring the interplay between Earth's dynamic processes and the mysteries of the cosmos deepens the understanding of the interconnectedness of the universe. The key concept is change, scale, and interconnectedness. Related concepts are mechanics, space technology, and exploration. And finally, the global context is orientation in space and time. So moving on to unit notes, the Earth's place in the universe. So starting off with the fundamentals, actual motion. Actual motion is defined as how objects actually move. For an example, it would be Earth rotating on its axis. And apparent motion is defined as how objects appear to move. So for an example, due to Earth's rotation, the sun appears to rise and set. However, it's not the sun that is rising and setting, it is the Earth that is moving that gives the appearance that the sun rises and sets. So little history, brief historical context behind apparent motion is that early astronomers developed the geometric model based on the apparent motion of the sun and the stars. And in this model, Earth is at the center of the universe. The geocentric model was later replaced by the heliocentric model. And in the model, the sun is at the center of the universe, but in reality, the sun is only at the center of our solar system and not the entire universe. Moving on to galaxies and gravity. We kind of went over gravity before, but we'll go over it once more. So galaxies. Galaxies are vast collections of gas, dust, and stars. And Earth's solar system is part of the Milky Way galaxy. So how are galaxies? So what is the organization of galaxy? Galaxies are often organized into groups or clusters, and the Milky Way belongs to a group of galaxies known as the local group. So Milky Way is just one galaxy out of the local group cluster. Gravity and celestial system. Gravity and celestial systems. So as a reminder, gravity is a force that attracts objects towards each other. It is a uniform force acting between all objects in the universe, and celestial systems, including galaxies and solar system, are held together by gravity. So now we'll go more in depth about gravity's impact. So gravity's impact. The strength of gravity depends on two factors, which is the mass of the objects and the distance between them. And the greater masses and shorter distances result in stronger gravitational forces. This will indicate that in a case of vice versa, where there's less mass and longer distances, it will it will result in weaker gravitational forces. So this is an example question of application so far. So the Milky Way is surrounded by many smaller galaxies known as the dwarf galaxy. The diagram below shows the relative distances of 3 dwarf galaxies from the Milky Way. All of dwarf's galaxies have roughly the same mass. So as you can see, it's Carina, Ursa Minor, and Draco, and this is the Milky Way. So which dwarf galaxy experiences the strongest force of gravity from the Milky Way? So based on previous context, the answer would be Ursa Minor, because the force of gravity between two objects depends on their masses and the distance between them. Therefore, the greater the masses and shorter the distance, the stronger the force in gravity. So in this case, all of the dwarf galaxies have the same mass, approximately. So we only need to consider distance. And according to the diagram above, the galaxy that is closest to the Milky Way is Ursa Minor. Hence, Ursa Minor experiences the greatest and strongest force of gravity from the Milky Way.